welcome to Forbest Academy and welcome back to our AMC 10-12 past paper question breakdowns. This week we've been looking at 5 AMC 12 past paper questions and breaking down the concepts needed to answer those questions. And our final question of the week today is involving the summation of a series and also looking at our natural logarithms. So the question is, when P, which is defined as the summation from 1 to 6 of k ln k, the number e to the power of p is an integer, what is the largest power of 2 that is a factor of e to the power of p? So the first thing I want to do today is to look at sigma, this symbol here, and discuss what this means and how we use it. So what this means is we are summating a series. We're taking a series and we're adding it together. And the series we've been given is k natural log of k. And we're told here that we're going to start. So this number at the bottom tells me my start point. We're going to start at k is equal to 1. And we're going to finish at 6. And we're going to add together all of those terms. So in this sequence here, we will have 1 ln 1 plus 2 ln 2 plus 3 ln 3 plus 4 ln 4 plus 5 ln 5 plus 6 ln 6. Now ln is what I call natural log. So that is log to the base of e. So ln is the same as log to the base e, which will be very, very useful later on in this question. So we remember from our earlier lesson this week, talking about logarithms, that the way a logarithm works is we are asking the question, what do I need to raise something to the power of? And the example I always give is 2 to the power of 3 is equal to 8. So therefore, log base 2 of 8 will equal 3, because we're saying, what do I need to raise 2 to the power of to get to 8? And the answer is 3. Well, if we look at our first term here, we've got the natural log of 1. What do I need to raise something to the power of to get 1? Well, we know that anything to the power of 0 is 1. So we can actually cancel out that term because we know that must equal 0. The other rule we looked at with our logarithms earlier this week is that if I have a coefficient in front of the logarithm, we can raise whatever's in our logarithm to that power. So with this here, 2 ln 2 can become ln to the power of 2 to the power of 2. Then we get ln 3 to the power of 3, ln 4 to the power of 4, ln 5 to the power of 5, and ln 6 to the power of 6. And again, we have another logarithm rule we can use here. When we have logarithms being added together, we can write them as long as they're the same base, which all of these are, there's all base e. If they're being added together, we can put them in one single logarithm by multiplying all of these things together. So that gives me natural log of 2 to the power of 3 times 3 to the power of 3 times 4 to the power of 4 times 5 to the power of 5 times 6 to the power of 6. Now, looking ahead in this question, I know that we were asked about the largest power of 2. So one of the things I want to do with our numbers here in this logarithm is I want to break them down into prime numbers. And the reason for that is so we can see exactly what power of 2 we have in there. So 2 to the power of 3 remains the same, 3 to the power of 3 remains the same. 4 can be written as 2 squared, so 4 to the power of 4 would become 2 to the power of 8. 5 is a prime number, so it would stay the same. And we can rewrite 6 to the power of 6 as 2 to the power of 6 multiplied by 3 to the power of 6. And finally, if we simplify all those terms together, we have 2 to the power of 16 I don't know why I've put 2 cubes there. Should be 2 squared. That's me writing down numbers incorrectly. So we have 2 to the power of 16, 2 plus 8 plus 6, multiplied by 3 to the power of 9, multiplied by 5 to the power of 5. So what we've done now is we've taken this series, which was 1 ln 1, 2 ln 2, 3 ln 3, 4 ln 4, 5 ln 5, 6 ln 6, and we've reduced it to one single logarithm. So that is equal to sigma from 1 to 6 of k ln k. Now we're asked the question, if we have e to the power of p, bearing in mind that this is what we've been told p is equal to the summation of this series. So we've got e to the power of p, which is e to the power of ln 2 to the power of 16 times 3 to the power of 9 times 5 to the power of 5. Now again, if we think about how logarithms work, natural log, so log to the power of e, we're asking what would we need to put e to the power of to get 2 to the 16 times 3 to the 9 times 5 to the 5. What we're doing is we're asking that question, and we're then raising e to that power. So what's going to happen is this is going to cancel with this. If we want that example with our log base 2 of 8, 2 to the power of 3 is 8. So this is the same as saying what's 2 to the power of log 2 of 8? Well, log 2 of 8 is 3, which gives us 2 to the power of 3, which just gives us 8. So it's like the log and the 2 have cancelled out. So we are left with e to the power of p is equal to 2 to the power of 16 times 3 to the power of 9 times 5 to the power of 5. And what is the largest power of 2 that is going to be a factor of this? It is going to be e to the power of 16. Thank you for watching this video today. Please like and subscribe the channel and stay tuned for more problem breakdown videos to come. We'll be doing one every weekday until the AMC tests this year in 2021. Next week, we're going to be breaking down 5 AMC 10 past paper questions, and I hope to see all of you for that. Thank you very much for watching, and I'll see you next week.